Hey there, welcome back. So in this video, I'm going to show you how to set up deepracer for cloud. So deepracer for cloud is a tool for training AWS deepracer models locally. This is a community maintained tool. You can run this locally on like an Ubuntu desktop or laptop. That's really the preferred environment to run it in. You could maybe get it to work somewhere else, assuming you can install Docker and Docker Compose, but Ubuntu is sort of the gold standard. I do not have a local Ubuntu machine to do this on right now, so you'll notice I'm actually in a Chrome incognito window connected on port 8443 here to a remote Ubuntu desktop. And I'm actually using a really cool tool to do this called Nice DCV, which I guess it's Amazon DCV now. I think Amazon bought them. This DCV viewer is a really neat tool that lets me have like a 3D accelerated, GPU supported remote desktop that I can use through a web browser from anywhere in the world, just as if it was a local machine. So super, super cool if I need a GPU, but I don't have one locally. Actually just super cool if I need a remote desktop that I can access through a browser, because this will do microphone and camera redirection, it'll do printer redirection, all kinds of cool stuff. But that's not the point. The point is everything I'm about to show you would work the same if you were doing this all locally on your own Ubuntu laptop or desktop. That's the important thing. Okay, so first things first, we need to check a couple of prerequisites before we go too far. Number one, I need to make sure I have FFmpeg installed. I may need that later on for dealing with video files that are produced from deepracer evaluation jobs. So just make sure you've got that. You also want to make sure you have this command called JQ. This is a tool for parsing JSON output. It's used in a couple of the init scripts for deepracer for cloud, and so you need to have it installed in advance. All right. You also need to make sure that you are in the Docker group and that you have Docker installed already. You can see I'm in the Docker group. There it is. Fantastic. So that is working as intended. You should make sure that you can run Docker as a non-root user. You might have to look at the Docker documentation on Linux post install. So that's, sorry, let me type that out, Linux post install. You should look for that on the Docker docs. If this doesn't work for you, they have instructions to fix it. Basically, this should work if again, you are in this group, the Docker group, then this should work for you. Okay. In my case, I actually have a machine that has a GPU. So if I run NVIDIA SMI, you can see that I have a Tesla T4 attached to this machine. So in my case, I should also be able to use that GPU from within a container. To test that that's working, you'd have to go over to the NVIDIA docs and sort of borrow this command. Whoops, sorry, didn't paste that correctly. Borrow this command, and that will run a container and have the container run the NVIDIA SMI command. And if you get printout like this, that's identical to the one that I just ran myself from the local terminal here, then that means the Docker container can see this Tesla T4 GPU as well, which is great. It means the Docker container can access and use the GPU. And I didn't need to be root. Ooh, sorry, hit my hand on the table. All right, cool. So that is now working. We've tested out sort of all the basic prereqs. Next thing to do is to follow along with the deepracer for cloud documentation and actually get deepracer for cloud installed. So let's go ahead and do that. All right, so first thing we need to do here is actually go fetch it. So we're gonna go get the deepracer for cloud install scripts. They actually come directly from GitHub. I'll link to the installation instructions in the comments below. But for now, what I'm just going to do is copy paste. I've got that up on another monitor, so I'll just paste in the git clone command. You can see I've now got deepracer for cloud. You know what? Let's make a code directory, and we'll move deepracer for cloud into there just to keep my documents folder clean. CD to code. Deepracer for cloud, and actually if you look in this bin directory, there's a couple of setup scripts, right? So like activate, we'll use that later. That basically just sets up environment variables for us so that we can run shortcut commands from the terminal here to start and stop training and evaluation jobs and stuff like that. The one we really need to run right now is init.sh. This is going to do some initial setup for us. It will pull down some container images if we don't already have them. I am going to run that in just a second. Before we do that, though, there's a couple of configuration things I want to do. I should also point out you should not run this. So the docs might tell you to run prepare.sh. If you're running on a local desktop, like a machine that you use for other things, like in my case, this is an Ubuntu desktop that I use for other stuff too, I really don't want to run prepare.sh because it's going to do things like set up additional disk partitions, which are only safe to do on a single purpose VM where I'm running deepracer for cloud and nothing else. Also, before we actually run init.sh, we need to do a little bit more setup. So let me see if I can find everything I need. Okay, that all looks good. Yeah, so yeah, actually before we do anything else, we're gonna have to run the init script. After that, there will be some additional env environment configuration stuff that's gonna show up here. You'll see that once we finish running /bin init. I'm gonna do -c, which says what type of cloud environment I'm installing into. It could be Azure or AWS. If it's local, you choose local. And again, I'm running this on an Amazon EC2 instance, but I'm gonna treat this like a local install. Then I choose A for architecture. The architecture I want is GPU. And I hit enter. That should fetch everything. I think in my case, I've actually already pulled the images, so this went really fast. Normally it would not be this fast. You would need 5 or 10 minutes while it downloads a couple gigabytes of Docker images, but it was pretty fast. And you'll see if I now look in my folder here, I've got these two guys, run.env, system.env. This one, these are system configuration parameters, right? These are actually going to control what happens every time I start up my environment and run things. And these run parameters, these are specific to the particular training or evaluation job that I'm running right now, and these might change on every run. I'm not going to go through all of them. They're documented pretty well already. There are a couple we need to change though. So let's go into here, GUI enable. So like dr GUI enable, GUI enable, that one will enable or disable the Gazebo GUI inside RoboMaker, which would let me log into the RoboMaker Docker container and actually see a Gazebo interface and control things from there. I'm going to leave that at the default, which is false. All these S3 bucket profiles and region names, we can leave that alone for now because, again, we're doing this all locally, right? So we're going to actually use MinIO as our pretend version of S3. MinIO is sort of an open source object storage alternative. So it's like open source S3. We'll leave most of these settings alone. Everything looks pretty good. I like to turn this one on in case I want to see what's going on with the RoboMaker logs. So I'm going to set that to true. We're not going to use CloudWatch logging because, again, we're treating this local. And you'll see there's a flag here for Docker style, right, that's been set. We are going to use Swarm. It's actually possible to use Compose now. We're going to leave that alone. We'll leave it the way that it is. And we're not going to touch that. Although I think for the OpenGL enabled images, we really should use Compose. You know what? Actually, let's actually do that. So if we are using OpenGL, there are a couple things we need to change. So let's just assume that we're doing that. So we're going to say, actually, you know what? Let's use Compose. So I'll set this to Compose, and we'll set this to true, both of which are required for the OpenGL enhanced images. Okay, great. So we've now done that. If we go to run.env, you'll see some settings here, like what racetrack we're going to use, what type of race, what is the car called, what does the car look like. You can adjust the shell style. deepracer is the default style for the car. When we evaluate, do we want to save an MP4 video? I kind of do. I like that. I'm going to turn that on. We'll leave most of the other stuff the way it is. Leave it at defaults. When we are ready to actually start using deepracer, we would do source bin activate. And let's see if this works. There are some issues with this sometimes if we didn't do our system.env and run.env correctly. So let's see what happens here. Okay. That is good. It looks like everything actually worked. Cool. And it did use Docker Compose. Fantastic. And the MinIO container is there and it's working. S3 MinIO 1 is running. So if I go do Docker PS, We have one container running right now. It is the MinIO container. What I should now be able to do is actually set up a training job and actually try running my first training. So let's give that a try. So let's see. There's a directory here called custom files. See that? Custom files. What I want to do is copy some examples over from this folder called defaults. So specifically from defaults, I'm going to need to copy hyperparameters. These are the hyperparameters for PPO, the training algorithm we're going to use to adjust our model. Put those in custom files. I'm also going to do that for the model metadata. This is the action space definition. So we'll again put that in custom files, and my reward function. So I need to get defaults, reward function, custom files. Great. And of course, if I now go into custom files, we can take a look at each of those and sort of see what they look like. So hyperparameters, you can see it's very similar to the default ones from the deepracer console. Model metadata, you can see that it is by default, it's a discrete action space with a very limited set of possible actions. But this will do for now. We'll leave it the way it is. We're not going to touch it. And then the reward function is the default centerline follower, just like from the console. So that stuff is now all stored in custom files. If we change any configurations, by the way, if we change anything in system.env or run.env, we need to run dr update. And if we change any of those custom files, then when we're done changing them, we need to do dr upload custom files, right? Which will actually push them into our fake MinIO bucket. And you're probably wondering how that worked, right? We didn't change any settings at all, right? So how did we manage to talk to MinIO, right? So that can be a little confusing. We just used the defaults. So MinIO's default config was taken care of for us when that container got booted up. I believe we can actually go log into MinIO if we want to. So I could go start up Firefox and then actually try to get into MinIO. But maybe we'll do that later, actually. I'll save that for a little bit later. And actually, you can see right now, again, because we have the S3 command installed and we're actually on an EC2, I can see all my buckets and stuff. We could change that so that we can actually, you know, direct this to point at MinIO instead, but we're not going to do that. If we want later on to talk to MinIO, we might have to make sure we've got the MinIO commands installed. I think they're called MC. Let's do that actually after we start and stop the training, because I don't want to show you that part just yet. Let's first try and run a training job. So all you would need to do from this terminal is dr start training. What should then happen is a bunch of stuff will take place to load up appropriate training jobs. However, we have a problem. That script depends on something else that's not installed right now. It depends on Bodo 3, which we don't have. So sorry, I actually did make a mistake. You need to have Bodo 3 first. Dr stop training. So let's stop the training, shall we? Because it's not going to work. So we'll stop the training, right? Try and stop that, and then in another terminal over here, let's open another terminal, right? And we're going to install. Let's make sure we have Python. Python 3. No, we do. Okay. Do we have Bodo 3 installed? Probably not. So we'll do we have pip? Which pip? We don't. So sudo apt get install. We want Python 3 pip. So you can see actually some of this stuff isn't explicitly mentioned in the install docs for whatever reason, but you do need to have JQ, FFmpeg, Bodo 3, some of these other things installed before you actually start using deepracer for cloud. So if I now go in and I were to do import Bodo 3, oh shoot, it's still not right because I haven't actually done pip3 install Bodo 3. Let's do that, shall we? Okay, user installation, site packages not writable. That's fine. We only need it installed for us. So let's open a new terminal session. So we'll start over. All right, first things first. Import Bodo 3. Do we have it now? Yes. All right, so now we have all the tools our scripts need to talk to S3, but of course if I do one of these dr commands, it won't work. Why? Because I need to run that source script every time, so don't forget about that. So do source bin activate, and of course I do that from inside my deepracer for cloud folder. If I'm not in there, that's okay. I just need to add more after source. I have to have the whole path to that activate script. Okay, so you can see that's now done, and I do dr update, and we do dr upload custom files, even though I've already done it. Those are now in our imaginary S3 bucket, and then we can do dr start training. And it might complain because we already started a different training job before. We might have to overwrite some things. We'll see how it goes. Yeah, it says the path exists. There's already been a training job run. W will overwrite that job. So be careful with that one. If you've already run a training before and you run -w like I just did, it's going to wipe out any previous models that you created. There is a way to increment the training, which I'll show you later. But if you add -w, whatever previous training job you ran, it's gone. So be careful with that one. And you can see everything's now starting up. We just need to wait a couple seconds to see if everything's going to work for us. And it's running. So how do we monitor it though, right? We can't actually see anything. So how would we actually check what's going on, right? Like how would we look at the training job? Well, we'd need to start the viewer for that. If we want to see what's going on, we'd have to use dr start viewer. So let me pop open another terminal window here, and we'll do source. Again, I'm going to have to do deepracer-for-cloud bin activate. Every new shell session, we'll have to run that. You could add this to your user profile. I don't like to do that. I don't want to have this thing running all the time. Okay, so let's go dr start viewer. And what that should do is start up a little viewer where we can actually see what's going on with all of our RoboMaker workers. We will only have one worker, but again, you can actually have multiple workers running. And you'll see we've set up, whoops, there we go. It's opening up automatically, right? And you can see there's our little red car, right? He's going around the track, learning how to complete the 2019 track as we speak. So it's working great. And again, I could probably make this full screen, but I'm not going to. You might want to do that if you're doing this on your own computer. And now we can actually watch the training process happen, right? And then what you would do is you'd let this go for an hour or two, and then you'd come back and see how things are going. If your model's looking like it's trained, then you would go ahead and stop the training, maybe run an evaluation, see how it does when you evaluate it, maybe do some log analysis. There's built-in Jupyter notebooks for that too. Again, take a look at the links in the description. The docs cover how to use those notebooks. But this is really everything you need to do local training. So if you want to give this a try, highly recommend it. And one other cool thing you can do here is you can actually switch cameras, which you can't do in the deepracer console, right? So I could see what the car is seeing, which is kind of cool. Or you can go to main camera, right? That's the above view, sub camera. This one is, let's see, what is this, top down or something? Oh, that one's actually not working. I guess I only have one camera on my car right now. But anyway, you can see the main camera or you can see the car camera. So I get different views of what's happening, which is kind of cool. And of course I can change the size and all that, but there you go. That's it. That's how you start a training job. And you know what? I'm going to leave this running and I'll show you how to stop it and run an evaluation. And then I'll also show you how you can actually get access to the files that are in that MinIO environment, right? Because you are going to have to download those files at some point if you want to then go upload them to AWS so that you can compete in a deepracer race. So we'll cover that in just a little bit. I'm going to leave this running and fast forward and come back in an hour. Okay, so as you can see, we've been letting this run for an hour or two, and we're now on iteration 10. Occasionally this does pop up, tracker miner FS. I don't know what this is. This is a thing that I have sometimes with Ubuntu 22 on EC2. We can ignore it though. It's not going to affect our training job. So I'll just say don't send that error report. If I go back here, let's see how our car is doing, right? So again, I'm doing this through VPN, so it's a little bit sluggish, but you can see it really looks like the car has done a pretty good job learning to navigate around the track. It's doing a way, way, way better job staying on track than it was before. So what I would then do is I'd go back here and I'd do dr stop training, and that will stop the training run. I'll also have to do stop viewer. The viewer is actually not going to shut down on its own. So I'll have to do that in a second once the training is shut down. They're actually separate components, so we'll wait for this to stop. Okay, dr stop viewer. Okay, that's now done. Docker PS, you can now see only container left running, and it's the one that we leave running all the time when we're using deepracer for cloud, is that MinIO container, right? So now we have another challenge, which is how can we access that? How can we talk to that? So let's address that next. How do we get in there and get files out of it? So what if we want a copy of the model that we just trained, right? Well, there are a couple ways we could go about this. Okay, so probably the easiest way for us to do this first is to use the MC command. This is the MinIO client. We can actually use this to copy stuff in and out of our sort of imaginary S3 bucket that we've got running in our MinIO container. So to do that, I first need to actually install the MinIO binaries, and I need to add them to my path. So we're going to run a couple of commands to do that, which I've pasted from the MinIO documentation here, and we'll wait for that to download, and we'll make sure that MC then loads up and runs, and you can see that it does. To make sure, however, that that happens every time, we do need to add the MinIO binaries to our path. So what I'm going to do is I'm going to open up. Actually, I don't need sudo for this. We'll just do bash rc, and you'll see here at the end what I'm going to do is, right-click and paste. What I'm going to do is paste this in so that MinIO binaries, which is a new directory I've just created, is now on my path, right? So MinIO binaries is now on the path. So if I were to say, close this shell and open a new one, hopefully what would happen, oops, that viewer is dead, so we can close that. Hopefully what would happen is MC will work. So let's make sure that that's actually the case. MC help. And you can see it says, okay, here are all the commands you can run: copy, find, get, all that good stuff. Very similar to S3, right? Let's make that window a little bit bigger. Let's go ahead and try connecting to a bucket. Okay, so now that we've got the MinIO command installed, if I run mcls, you'll see that right now, at least, it's actually listing out just the files and folders in my home directory here, which is not what I want. I want it to talk to this, right? We've set up a Docker container here that's running MinIO, and I want to be able to talk to that. So what I'm going to have to do is run the mc host add command to actually add a new account. So let me show you how that works. So it's actually pretty straightforward. It's just a fairly long command. What we're going to end up doing here is this: mc config host add, and then I need to give it a name. We'll call it dr for deepracer. We'll say localhost 9000, right? That seems good. And then I need to put in the access key and secret key. Those, I think, by default are actually the same as the default username and password, which I think is MinIO admin and MinIO admin. So I should be able to do this, but we'll see what happens. Okay, so you can see it complained. So what that probably means is that the username and password for this MinIO bucket are not what we think they are. So there are a couple places we can start looking around to figure out what those are. So let's do that. So let's see if we can figure out what this whole command was. Maybe there's some kind of a password override in there. So we'll do docker inspect s3 minio1. Oops, sorry, a little extra apostrophe on the end there. Let's go and look through the settings for this thing and see if there's anything obvious in there that would tip us off as to what the username and password might be. All right, so those are all the sandbox settings, release info, MinIO project info. All right, great. That's all fantastic. I don't see anything in here yet that would indicate access key, master key, any of that stuff. Oh, look at that. Username, MinIO root password is this. Oh, okay, so it is in there. And the MinIO username is Ubuntu. Okay, so these are actually the things that I needed. So what I'm going to do is I'm going to grab this because I'm never going to remember that. And the username is pretty easy to remember. Oh my gosh, look at that. So the MinIO username is Ubuntu. The MinIO root password and root user are this, which is just some randomly generated string. Let's try using, okay, we're actually going to need to save all of that because I might need that information later. So I am just going to stick that. Well, you know what? I'll just open a new terminal window. So we'll open up MC over here, right? And we'll do, what was it? I think it was MC host add, right? It's a long command. I have a hard time remembering it. So MC config host add dr localhost 9000. And then we need our root user. That's going to be the access key name, which is this crazy thing. Copy. Paste that in there. And then we're going to need this, the password. Take that. Copy. Paste it in there. Added dr successfully. Fantastic. So now if I do mcdrls, mcls, nope, that's still listing the local files. Hold on, I need to figure out how to do this. I think I just do mclsdr. Yeah, there you go. So that worked. So we start everything with dr, and I can say bucket. Look at that. And then in here, rl deepracer SageMaker, right? So that is the stuff that rl deepracer SageMaker is going to be where my model files are. So you can see there's the metrics, the output, the model, the reward function, all that stuff that would normally be a part of the deepracer model. So if I wanted to then take this stuff and import it into the deepracer console, I could do that. I could take the stuff from the dr bucket and sync it locally somewhere and then upload it to a S3 bucket and continue my training from the AWS deepracer console. So just to demonstrate that, we're going to go back into documents here, and we'll do, I think, mc sync dr to local. I think that, okay, you can't do that, but we could do a copy. So you can do mccp recursive dr to local. And then you'd see, okay, it's now done that. It's 900 megs of stuff. If I go into bucket, there's now a copy of the RL deepracer SageMaker and the custom files and all that stuff. You can see training sim trace here, right? So we got all the data from the training job. I can see my outputs, so that's the model itself. I can see metrics related to the model, right? And then if I go into IP, you can see the hyperparameters for the model, right? So this is what was used to train the model, the PPO settings, right? All that good stuff is in here now, right? And if I were to do a training job, or excuse me, an evaluation job, any evaluation videos would also, I'd be able to sync them over the same way. That's one way. The other way to do this would be through the AWS CLI. I don't want to do that because it gets confusing. If I'm using the MC command to deal with MinIO and the AWS command to deal with AWS buckets, then it'll be way easier for me to distinguish which environment I'm working in. The AWS CLI can talk to MinIO and treat it like S3. I don't want to do that because I also actually want to talk to S3 later on, and I don't want to get confused about whether I'm talking to a real S3 bucket or using a MinIO bucket. So what I recommend you do is use MC to manage all your MinIO files and use the AWS S3 command to manage S3. And if you wanted to, you can also actually access MinIO through a web browser. So if you prefer to do that, the way to do that would be to go to localhost 9001, and then this username and password here, what you would actually do is, again, these are the ones from the docker inspect command that we just ran, right? So if I take that and I do copy, and I go back and I do paste that in here as the username, super long, ugly username, and then if I go back and do the same thing for the password, so whoops, just this part, copy. And then we, we go back and we paste, log in, save those, and of course, there you go. Now you can see I have sort of an S3 style interface here, and I can click on bucket, and there's all my stuff. And of course, I can upload and download and delete and do all that from this web interface as well. All right, so now you know how to train a model, pull that model out of MinIO storage, and do all that stuff locally on an Ubuntu host. The only other thing you might want to know how to do is to increment a training job. So there is a command for that. So I'll just show you that. So I'm going to close both of these terminal windows and make a brand new one. Make a brand new one, right? Okay, here it is. Make it a little bigger, and we'll do documents code, and we'll do source, deepracer-for-cloud bin activate, right? And then I've got all my DR commands again that I can run. So there is a DR increment training, which will continue the training from the last model. So this is very similar to in the deepracer console when you make a clone. DR increment training is going to do that. It will continue from where you left off with your previous model, but using your new hyperparameter settings and your new reward function. Assuming, of course, that you have run the dr upload custom files command first. Don't forget to do that if you're going to increment training. And of course, you can also run dr start evaluation to run an evaluation on your existing model, which is also pretty cool. So you know what? Let's actually do that now, and I'll show you what that looks like. So we'll let an evaluation run, and then what we're going to go in, what we'll do when the evaluation is done is we'll go back into Firefox and look in MinIO and see if we can download the evaluation video. This job, I believe, should stop on its own. We shouldn't need to stop the evaluation on our own because it should just run until completion and then stop. But, you know, we'll see what happens. So I'll fast forward through this. And here we are a couple of minutes later, and you can see that, yes, indeed, the evaluation job has conclusively ended itself, which is fantastic. And it looks like there are a couple of minor warnings here from Compose, Docker Compose, but I think we can probably ignore those. If I open up Firefox and I go look in our little bucket here and go to RL deepracer, look at this. There's a new evaluation params file and a new evaluation folder. And in here is an evaluation symtrace, right? So that should be the data from the evaluation run, right? And maybe if I'm lucky, there will be an MP4 folder. Yeah, indeed there is. And look at that. I can see 3 different camera angles from my evaluation of this model. So if I now were to say download this, I should be able to take a look at those videos, assuming I have a video player. I don't know if I've installed one yet on this machine, but you know what? Let's just go for it. So I'm gonna go here, and we will do the thing we just did a minute ago, which was MC, and then I think it was CP recursive, and we'll do our DR bucket, and we're just gonna put all the DR stuff here, right? And there we go. It'll download a couple hundred more megs of content. And I'm going to open that up in a file browser and we'll see what happens. Again, I may actually need to go install a video player. This desktop is pretty sparse. Haven't installed much of anything here. Let's see what we got. MP4. Look at that. 45-degree camera angle. Video 1. Let's see if that pops open. Might be a little stuttery. Okay, yeah, I don't have the ability to play that, but that's okay. We can install a video player that will handle that. So sudo apt-get install VLC, I think, is a good one. So let's grab VLC real quick here and see if that gets us back in business. So we'll give that a second to unpack and install. Awesome, so that's now installed. So if I go back, hopefully I'll have the option now. I might have to right-click. We'll open with another application, and we'll say, you know what, let's use VLC. And let's see what happens. Sure enough, yeah, that one works. Fantastic. And look at that. There's our little guy going around the track. And again, okay, so he's not, probably need to keep training this model for a couple more hours. It looks like it's not all that well trained. Our very first thing we did was go off the track, which is not the best. So probably this model needs a little bit more training. But you can see we've successfully evaluated it. We've been able to get the evaluation metrics saved in a CSV file, and we've got these 3 different video outputs that we can look at as well, which is pretty cool, right? So we've managed to teach this car to mostly make its way around the track in a couple of hours, and we've done it all without the AWS console. We've been able to do it all in a quote-unquote local environment, which again for me is an EC2 instance, but you could do this on pretty much any machine running Ubuntu, you know, assuming you have enough memory. We'd recommend something like 16 gigabytes to run this, you know, smoothly, but you could maybe get by with less. The point is you can run everything locally if you want to. All right, that's it. Hope to see you in the next video.